Article 225.33 and 230.71 address the maximum number of disconnects at 6. The rationale is that this requirement limits the number of disconnects in a series to 6 to prevent excessive voltage drop. It also avoids creating a tripping cascade where the opening of one disconnect causes the opening of subsequent disconnects. Article 404.8 specifies the maximum height of switches at 6 feet 7 inches. The rationale is that this requirement provides a comfortable reach height for most people, ensuring easy access to switches without the need for ladders or stools. Article 408.15 dictates a maximum of 42 overcurrent devices. The rationale is that this requirement limits the number of overcurrent devices in a single panel board to 42 to avoid overloading the panel and to ensure proper heat dissipation within the enclosure. Article 550.10d governs mobile home cord lengths, specifying lengths not less than 21 feet and not to exceed 36.5 feet. The rationale is that this requirement ensures that the cord is long enough to reach the service equipment, but not so long that it creates a trip hazard or interferes with the safe operation of the mobile home. Article 110.26e pertains to warning signs at service equipment. The rationale is that this requirement aims to prevent accidental contact with live parts by providing clear warnings at the point of service. Article 210.12c concerns the grounding electrode system. The rationale is that this requirement ensures proper grounding of electrical systems, reducing the risk of electric shock and damage to equipment. Article 310.15b3 addresses raceway fill. The rationale is that this requirement limits the amount of conductors allowed in a raceway to prevent overheating and ensure proper heat dissipation. Article 430.36 covers motor nameplate requirements. The rationale is that this requirement provides essential information about the motor, including its horsepower rating and operating voltage for safe and efficient installation and operation. Article 517.74 discusses receptacle outlets in hospitals. The rationale is that this requirement ensures that there are sufficient outlets available in patient care areas for medical equipment and convenience. Let's delve into these rationales a bit further to provide a more comprehensive understanding of their implications and applications. Considering the disconnect requirements outlined in Articles 225.33 and 230.71a, it's important to recognize that the limitation of 6 disconnects is not arbitrary. It's rooted in practical electrical engineering principles. Exceeding this limit can lead to cumulative voltage drop across multiple disconnects, which can negatively impact the performance of downstream equipment. Furthermore, the cascade tripping scenario is a significant safety concern. If one disconnect fails or is intentionally opened, it can induce voltage transients or imbalances that trigger the opening of other disconnects in the series, potentially leading to a widespread power outage or equipment damage. The 6 feet 7 inches height restriction for switches, as mandated by Article 404.8a, is designed with human ergonomics in mind. It represents a compromise between accessibility for the majority of adults and the need to prevent accidental activation by children or pets. While there may be exceptions for individuals with disabilities or specific installation constraints, this height standard aims to promote ease of use and reduce the risk of strain or injury when operating switches. Regarding the panel board overcurrent device limit of 42, as specified in Article 408.15, it's crucial to understand that this limitation is related to the physical capacity and thermal management capabilities of standard panel board enclosures. Cramming more than 42 overcurrent devices into a typical panel board can lead to overcrowding, making it difficult to properly terminate conductors and maintain adequate spacing between devices. This overcrowding can impede heat dissipation, potentially causing the panel board to overheat and increasing the risk of insulation breakdown or even fire. Now consider mobile home cord lengths, as stipulated in Article 550.10d. The rationale behind the 21 feet to 36.5 feet range balances practicality with safety. A cord shorter than 21 feet might not be sufficient to reach the power source in various mobile home setups, forcing the use of extension cords, which are generally discouraged due to potential hazards. Conversely, a cord longer than 36.5 feet can create a tripping hazard, become tangled, or be susceptible to damage from being run over or pinched. Additionally, excessively long cords contribute to voltage drop and increased resistance, potentially affecting the performance of connected appliances. Warning signs at service equipment, as mandated by Article 110.26e, serve as a critical visual reminder of the potential dangers associated with working on or near live electrical components. These signs typically include warnings about high voltage, shock hazards, and the need for qualified personnel to perform maintenance or repairs. By clearly marking service equipment, these signs help prevent accidental contact with energized parts, reducing the risk of electrical injuries and fatalities. The grounding electrode system requirements outlined in Article 210.12c are fundamental to electrical safety. A properly installed and maintained grounding system provides a low-impedance path for fault currents to flow back to the source, allowing overcurrent protective devices such as circuit breakers or fuses to quickly trip and energize the circuit. This rapid clearing of faults minimizes the duration of potentially hazardous voltage exposures, reducing the risk of electric shock and limiting the damage to equipment caused by ground faults. The raceway fill limitations described in Article 310.15b3 are designed to prevent overheating of conductors within raceways. When conductors are packed too tightly within a raceway, they cannot effectively dissipate heat, leading to a rise in conductor temperature. Elevated conductor temperatures can degrade insulation, reducing its dielectric strength and increasing the risk of short circuits or ground faults. By limiting the number of conductors allowed in a raceway, the code ensures that conductors operate within their safe temperature ratings, extending their lifespan and enhancing overall system reliability. The motor nameplate requirements detailed in Article 430.36 are essential for ensuring the safe and efficient operation of electric motors. The nameplate provides critical information about the motor's electrical characteristics such as its rated voltage, current horsepower, and speed. This information is necessary for selecting appropriate overcurrent protection conductors and control equipment. It also helps ensure that the motor is operated within its design parameters, preventing overheating, premature failure, and potential safety hazards. The requirement for sufficient receptacle outlets in hospital patient care areas, as addressed in Article 517.74a, reflects the unique electrical demands of healthcare facilities. Patient care areas often require a high density of electrical outlets to support a variety of medical equipment, including monitoring devices, infusion pumps, and diagnostic tools. Ensuring an adequate number of outlets reduces the need for extension cords and portable power strips, which can create tripping hazards and increase the risk of electrical interference. Moreover, it helps maintain a reliable power supply for critical medical equipment, minimizing the potential for disruptions in patient care. These detailed rationales underscore the importance of adhering to the National Electrical Code. The NEC is not simply a collection of arbitrary rules. It is a comprehensive set of safety standards developed by experts in the electrical industry to protect people and property from electrical hazards. By understanding the reasoning behind these code requirements, electrical professionals can make informed decisions that promote safety, reliability, and efficiency in electrical installations. It's also vital to stay up to date with the latest edition of the NEC, as code requirements are periodically revised to reflect advancements in technology and address emerging safety concerns. Consistent application of the NEC guidelines is the cornerstone of electrical safety, reducing risks and ensuring compliance. Understanding these requirements in detail is vital for any professional working in this field.